Good morning students. Today we are going to see the data serialization in using 8051C. So what is meant by serialization? So data in the sense you can send the data bit by bit or as a byte of data depending upon whether it is a type of serial communication or parallel communication. So here data serialization means serializing the data means it is a sending a byte of data one bit at a time through a single pin of a microcontroller. So there are two ways of transferring the byte of data serially. So one is by means of using a serial port. So when you use a serial port, the programmer will have a limited control over the sequence of data transfer. So the detail of serial port data transfer will be discussed in the further classes. So data serialization means sending a byte of data. A byte is nothing but 8-bit. So sending a byte of data as a bit by bit data through a single pin in a microcontroller. And this could be done in two ways. The one way is nothing but using by means of your serial port. So when you use a serial port, the programmer will have a limited control over the sequence of data transfer. Whereas the second method of data serialization is transferring one bit at a time and control the sequence of data and spaces in between them. So for example, if you are transferring a byte of data a bit at a time. So once one bit is transferred to that particular pin, then immediately the second bit of data will be entering. So here the data bit and the control and sequence of the data and the spaces is managed between them. So in many new generations, such as in many new devices like LCD, ADC and ROM, the serial version are becoming very popular, so that it takes a less space in case of your PCB board. That is, while designing a PCB board, when you use this type of method, it takes a less amount of space when designing your PCB. So serialization, as we discussed, it is sending a byte of data one bit at a time through a single pin of a microcontroller, and we are going to use a serial port, and transferring only one bit at a time will control the data and the spaces in between them. So in many new generation devices such as LCD, ADC and ROM, the serial versions are becoming popular as it takes a less space when designing your PCB. So it is your serialization. This is how your data will get serialized in case of your 8051 microcontroller. Now write a C program to send the value 44H serially one bit at a time via port 1.0. The LSB should go first. So only one bit it should go. Here which bit, whether LSB bit should go first or MSB bit should go first, that matters a lot. To access all 8051 library function, first we need to include the header file #include reg51.h. I wanted to define P1.0, that is 1 bit. If I want to define, I have to use S-bit data type. P1.0 I am going to define. So just keep some number, any variable like P10 is equal to, I wanted to define P1.0 as like this. Then 44 in the sense 0100 0100. Okay, so in this one bit at a time means we need to consider whether LSB should go first or MSB should go first. In this program, LSB should go first. LSB in the sense 0 first it should be transferred, then 0, then 1, then 0. Likewise, the data transfer should happen. For that, I am going to consider one more variable, S-bit, REGALSB, accumulator. So because accumulator is going to transfer the data in that 0th bit alone. So for that 0 we are specifying. Then void main, going to start a main function, unsigned char, con byte 0x44. What data I need to transfer, that I am going to use it with one variable. Unsigned char x, since it is a 8-bit data, you are going to use it as ACC. Since only one byte of data we are going to transfer, we are going to consider one variable ACC is equal to con byte. So among this 8 byte of data, only that LSB. So LSB bit should go first. For that, for x is equal to 0, x less than 8, x plus plus, P1B0 is nothing but it is your bit that representing P1.0. There first you are going to send the LSB bit which is mentioned with the variable REGALSB. Then you are going to like this, if your ACC like this, if you are giving means it is right shift the accumulator content once. It means that 44 0100 okay. First 0th bit is already transferred in this particular line. Then I have to shift 1 bit right. 1 bit right means again after sending this 0, again this 0 should come. Then again this 1 should come. So to shift 1 bit right and make the data to move forward in port P1.0, we are giving the line ACC equal to ACC arrow mark 1. So it is nothing but shift right 1 times. Okay. So this is how you will be sending the data serially to port 1.0. Here the LSB is going first. Now suppose if I wanted to send MSB data, for example 0144 0100 0100, if I wanted to send MSB data first this 0 should go, again this 1 should go. If I wanted to transfer the data serially, first MSB means 2 changes will happen. One is here S bit REGAMSB. In this place you need to write it as ACC7 because my 7th bit should go first. And after transferring my 7th bit in this point, here it should move left. So for that one more instruction what we need to give is ACC is equal to ACC. I need to shift left once. So instead of these 2 lines, if you change like this, you can transfer the data same 44 with MSB as a first data entering in port 1.0. This is one difference. That program only I have shown over here. Here also we have write a C program to send the value 44H serially 1 bit at a time. P1.0 MSB should go first. So MSB should go first in the sense here P1B0. I am going to define 1.0 in the variable P1B0. Then I am going to consider my 7th bit because that is my MSB bit as ACC7 with in the variable REGAMSB. All these programs will define how exactly we are going to load the data. This is loading the data in the variable con byte. Since 44, it means that 00 to FF means we can use unsigned char. Unsigned char con byte is the variable storing the value 0x44. Then loading this con byte data in your accumulator. Then transferring only the MSB byte of data to port 1.0. Then I need to shift my after transferring, that is 0100 0100. After transferring your 7th bit, again the 6th bit need to be transferred. It means the left shift should happen. For that we are giving ACC equal to ACC left shift operator 1 time. So this program will transfer the data 44 serially in port 1.0 by transferring MSB data first. So here write a program to bring in a byte of data serially 1 bit at a time via port. So you need to bring the data from port 1.0. The LSB should come first. LSB should come first in the sense here I can write same, all these terms is going to be same. Just I am going to give a left right shift operator. Here you are going to see the MSB should come first. Hash include this particular header file access all 8051 library function. Then to define this port 1.0 we need to use S bit, that is single bit P1.0. Then I am going to assign one value where it is going to take a byte of data serially, 1 byte at a time, where the MSB should come in first. MSB only should come in first. Then bit is equal to M bit, because it is going to handle only 1 bit of data. Unsigned char, since X is going to carry the data from whose ranges from 0, 0, it is not going to carry any of your signed data, so we are going to give unsigned char. 8 bit of data, so X is defined with X is equal to 0 to X less than or equal to 8. Then this mem bit is going to carry the data from port 1. In the previous two programs, we will be transferring the data to the port 1 or port 0, port 1.0. From here, now the data will be transferred. From the port will get transferred the data. Now the port 1.0 will transfer the data to a particular variable wherever we have mentioned. And since MSB should come first, we are going to have a left shift operator with respect to the accumulator content. Then you are going to load that memory bit in the REG ALSB memory bit. Then P2 is equal to accumulator content. Thank you, students.